So I was asked this question today and I thought I would video the answer to first of all be able to share it easily with the person that asked me, and it might be useful to some other people. So this is a question on complex numbers, and this came from the May-June 2017 paper 33. And it was question 11. I think it was part B. Okay, so we've got the complex numbers. U is this, V is this. You can read that if you want. We're told that the distance between A and B, which are those U and V numbers, so this was A, I'll just note that, and this was B. If we double that distance, we can find out that C, another point, is twice of this distance away from B, and also that the angle ABC is 90 degrees. So first of all, I'm going to just plot that onto my diagram. I already pre-prepared the diagram just to save a bit of time, but if this is AB, if we double that length and make this angle 90 degrees, and C has to be in the first quadrant, so C's got to be somewhere up here. Okay, now this actually did take me quite a bit to wrap my head around this question, but it's actually quite deceptively simple. Okay, so if we know this distance here, we want to go twice that distance, but in this direction. Okay, so first of all, we need to figure out this bit here. Now, if we use what we know about complex numbers, and let's label this something else. Now we've used U and V already. Let's call this a W. Okay. We know that if we go along here, so this the B one was the V, and this up to A was U. So if we do V plus W, we will get U, just from thinking of them like vectors, but that's how complex numbers work. So if we substitute in what we do know, then we've got V is 3 plus 2i. The W is the bit we don't know. And if we add them together, we will get that equal to 1 plus 2 root 3i. And then you can do it just by working out what the bits have to be. So the real parts, 3 add on something has to make 1. Well, that has to be a minus 2. So 3 plus 2i add on minus 2. And then to get from 2 to the 2 root 3, so from this one up to here, we add on the difference between those two heights. So this will be add on 2 root 3 minus 2 lots of I. I'm not going to do anything more with that, try and simplify. We're just going to leave it as that, and that will give us our answer 1 plus 2 root 3i. Okay, so we have an expression for this W complex number here. Now that we can also express down here as the exact same complex number if we plotted it separately. So W would be this minus 2 plus 2 root 3 minus 2. Okay, so it goes up to minus 2 here, and this bit here would be the 2 root 3 minus 2i. So this minus 2 plus this as a complex number, that would be there. So it go up to the 2 root 3 minus 2i. Okay. Now we want to figure out that complex number. I do actually think about these quite a lot as vectors. So if we turn that vector around 90 degrees and then shoot it off in twice the length, it will get us what this length needs to be. Okay, so to rotate this 90 degrees, think about this triangle here. That minus 2 will come up and be the y value, and the 2 root 3 minus 2, that will turn around and become the x value. So if I just switch my colour here so you can see, if we take that W and we now go off in that direction, the same distance, but we've turned it 90 degrees, then this one here will be that we have to go 2 root 3 minus 2 as our x direction, and then plus 2i there. So I'll write it out so you can see it a little bit better. That was 2 root 3 minus 2 as the bit that's along the x direction, because that was this part of the triangle. So if we turn it around that way, that'll be this part here. And then add on the y direction, the complex part. So that'll be this part here has got turned up here. So that'll be that part there, and that'll be plus 2i. Okay, now we have a complex number to take us in the right direction, and we know that 2 lots of them, so if we put one here and one here, do 2 lots of them after we've started at V, that will get us up to C. So now, to get Z, which was our complex number representing C, okay, so this is Z up here, we're going to do V, so this point here, so we're going to get to that point there, and then we're going to add on 2 of these new complex numbers we just worked out here. So that'll be V, add on 2 lots of 2 root 3 minus 2 plus 2i. Okay, so V was 3 plus 2i. And so we tidy that up. We've got 3 minus 4 is minus 1, plus 4 root 3 plus 6i. And there you have Z.